Okay, wait, are we back? Okay. Okay, this is now chapter 2, part 2. We are going to continue working on the chapter 2 questions. Okay, no, stay on this page. Okay, so I am still going to have my Excel homework 2 open here. And let's grab a new tab. Okay, so a manager at a local restaurant records the number of customers who ordered each of the 4 types of entrees, and the table summarizes the results. Alright, so here we just want to copy this. Sorry. So much going on here. Okay, let's restart. Done. Okay, we are back. This is chapter 2, part 2. I have got the pie chart question open here, and I've got my Excel workbook for chapter 2 open as well. Let's go ahead and grab the data here. It's asking me for it in tab format. That's the default. Remember here, if I keep the text only, yeah, I think they'll copy nicely. And if I just grab this data, you can do it visually too, like just in your head. But just so we're all on the same page here. This is kind of just a quick and dirty way of doing it. But interestingly enough, kind of actually corresponds to the color wheel in my stat lab. Usually it may not do that. So blue being beef, the orange being fish, gray being chicken, and yellow being vegetarian. Here we've got A, B, C, and D as well. So blue, red, green, and yellow. So which looks the most like what we have going on here? And it looks like it's likely going to be C here, because definitely the blue doesn't take over half. If we want to add labels, we can always do that too. And the way I did that, just grab the data, put it into a pie chart. Alright, next up we have got a contingency table, which is actually a pretty powerful tool in statistics, and it allows us to do it in Excel nicely. Okay, and it looks like this. I can select this data. Make sure that you select the labels as well. Insert a pivot table, and the default is fine. You can just select yes. And what's going to happen is there's going to be a new sheet that opens down here, and it's going to contain an empty pivot table. And a pivot table is just what Excel calls a contingency table. A contingency table is determining whether or not one variable is contingent upon another variable. So if we want to replicate and have it look exactly like it does on my stat lab, we're going to take these 2 variables that have different values or levels underneath them, and put gender as a row, because that's how it is in my stat lab, and major as a column. Note here that the labels are reversed across the 2 systems. So in my stat lab it is male first then female, and in Excel it's alphabetical, so you may want to just reverse that. And once I click out of the pivot table, you see that the interface disappears, so to get it back you just click back on it. Okay, so Now what we're going to do is tabulate by simply taking, you could take either gender or major. I'll just take gender, and I'm going to put it into values. And nicely enough, the default is in my system is count, which is exactly what we want. If you see zeros there, it's because your default setting is set to something else, like the sum. I think, yeah, that's what it would be. So if you're seeing zeros as your values, just go into, click on this drop-down box, go to value field settings, and indicate count. Then hit OK. And again, the same is going to be true if I had put in major. It's just giving me a cross tabulation here. Okay, so now what I can do, I've made it so that the males are consistent with the labels is in my MyStatLab and Excel. So let's just go through and do this. 3. Now I hit enter there and it went across. So just make sure when you are putting the data in that you're being careful, because I've had to redo some videos. Oh, that's interesting. 3. That's why. Okay, so 3, 1, 1, 5, 3, 1, 3, 7, and 6, 2, 4. Okay, check that. Nice. As you saw before, I had put in 13, so that wouldn't have been good. What conclusions can be drawn about the students' majors? So here what you can actually do is you look to see for the majors, are these values the same? Are there the same number of accounting as there are computer science, as there are marketing? Sorry, I had to look what C was equal to. And it looks like computer science is significantly less. So the majority of the sample students are accounting. Oh, nope. Not accounting. Oh yeah, accounting. Whereas the fewest are computer science. Because 6 and 2 respectively. And let's see, what conclusions can be drawn about each gender's major? So here what we're looking at is the differences between this number and this number, this number and this number, this number and this number. So there are the same number of female and male for accounting, for computer science, and there are more females than males in marketing. Okay, let's construct a stem and leaf plot quickly. And the first thing I'm going to do is select the data, go into data, sort, and smallest to largest is how I want to sort it. And so here I see that I've got values ranging from 77 to 117, meaning that there are values that fall in the 70s, 80s, 90s, 100s, and 110 ranges. All the stem and leaf plot is asking me to do is say, well, there's values of 70, that's the stem is 70, and the leaf on 70 is 7, because it's at 77. Similarly, this 80 is going to be the case here. 3, 4, 5, 6, 9. Now when I click underneath here, this 0 is going to disappear. So what I'm going to actually do, well, I'll just illustrate it. So see, because it doesn't want to have leading zeros, so I'm just going to put a decimal place there. And then it's going to give me a leading 0 in front of it. So if you have a 0, you may want to, there's a couple different options. Just be careful. You can put a 0.0, but then it's going to give you an extra 0. If you don't put the point, it's not going to give you the 0, or you can save it as a text. So in this case, 2, 6, 7, 8, 101, 2, 6, and 113 and 17. Okay, so all I'm going to do here is 7, 0, 3, 4, 5, 6, 9, 2, 6, 7, 8, 1, 2, 6, and 37. Let's make sure this is correct. Great. Just to be clear, what we're doing here is looking at the distribution. So we see that the majority of the data here is towards the lower end of the distribution, in the 80s specifically. Okay, now in this ordered stem and leaf plot, let's grab this, copy to clipboard. And it's wanting to construct an ordered, splitting the stems from part A. Okay, so sort, it's the largest, and again here 2, 3, 4, 5, let's see. Okay. Now this next part is actually going to ask me to split the stems. So what that's going to entail is having 2 stems for each of the values of 20, 30, 40, and 50. So we'll just do part A first. Just for the purpose of this exercise, I'm going to format the cells to be custom, or text. I'll do text. Just because I might have some zeros that I need to put in there that I need to be captured as leading. So 25, 26, actually 2 26s, a 27, 1, 2, 3 28s, 29. I also have 30, 31, 2 32s, a 35, a 36, a 37, and it looks like 3 39s. It's giving me an error here just because it's saying you're storing numbers and we're storing it as text, which is fine. Again, I want to capture those leading zeros. 41, 42, 43, 45, 46, 48, and 49. 2 50s, 2 51s, 2 52s, 2 53s, 54, 56, 58, and 59. Okay, so this is going to be a bit easier now to copy this into my stat lab. 9, 0, 0, 1, 1, 2, 2, 3, 3, 4, 6, 8, 9. Nice thing about my stat lab is it you can log out and log back in. Okay, now we're going to split this stem and leaf plot, and here they're asking me to split it in terms of anything that's above 25, 30 to 34, 35, 40 to 45, and then 50 to 55. So if I just take a look here at anything that falls above 25, you see 25, 26, 20, 9, 9, 9, 1, 2, 3, 3, 5, 6, 8, 8, 9, 0, 0, 1, 1, 2, 2, 3, 3, 4, 6, 8, 9. Nice. Okay. Now for this one, let's copy this. Now importantly here, it's important to note this is time series data. So we've got all the different quarters here. And actually, the way you can kind of think about this, I'm just gonna transpose this quickly. is that these are the 4 quarters for 2006. These are the 4 quarters from 2007, from 2008, from 2009, 2010, and this last one, the first quarter of 2011. Let's see if I can. No. Just so we're clear here. 2008, 2009, 2010, and 2011. Made it so that these are ascending in order according to time. And this is the timeline that we want to graph. So let's insert this, graph this, and we see something like this. And so the best visual representation of this time series data, quarterly data I should say, is that final one. Okay, only 3 hours later. All right, everybody. Oh, wait a second. Are you kidding me? Is this it? 10 out of 10? Save. What? Oh, I sure want to leave this question. No. What's happening? Oh. Where's the relationship? It's going up. Final check. All right. Done. That's it for chapter 2. Homework. To be continued in chapter 3.